So if you're taking this class online or you're at home, you may want to print off a copy of the note sheet today to write on. You're always welcome to come by my room and grab a copy of the note sheets for a unit if you're an online student. So what we're going to do today is continue with the algebra of functions, and we're going to deal with products and quotients mainly. So I'm going to start off. I have a function f and a function g. Notice here I have input. I could put a value in for x and I would get an output. Here I could do the same input and I would get a different output. What we're going to try to find is what happens when I take the outputs of f and g and multiply them together. So I'm going to start off by making a table of values for x, and f of x is the output. And then the same table of values for x and make g of x the output value. Let me grab a pen so I think it'll be easier to see. Thought I could write dark enough with a pencil, but I can't. So I'm going to try the same input values for both functions. So I'm going to go -2, -1, 0, 1, and 2 for the input value, and I'm going to do the same thing over here. And I'm going to create a new function that uses the same input value, but this time the output value is going to be f times g. So let's start off with the f of x function. I'm going to put -2 in for x. So 2 times -2 is -4. And I put -1 in. 2 times -1, -2. 2 times 0 is 0. 2 times 1 is 2, and 2 times 2 is 4. Then I'm going to find the output value in the g function for the same domain. So I'm going to put -2 in for x. 3 times -2 is -6. -1 is -3. 0 is 0. 3 times 1 is 3, and 3 times 2 is 6. So now, using the same input value, I'm going to create an output value of multiplying the f function times the g function. So we're going to use the same input values. But to find f times g, I'm going to multiply the output of the f function times the output of the g function. So at -2, I have -4 times -6, which is 24. At -1, I have -2 times -3, which is +6. At 0, I have 0 times 0, which is 0. And at 1, I have 2 times 3, which is 6. And at 2, I have 4 times 6, which is 24. So if I graph this, -2, 24, that's off the chart. -1, 6. 0, 0, 1, 6. So you can see that when I take the outputs of this f function and multiply it times the output of the g function, I get a new function. And this new function, even though the first two were linear, this new function becomes a quadratic function. And you can see how that works by using the graph. Now, we don't always want a graph, so I want to show you using the algebraic method. When you see f and g next to each other, this means you're going to take f times g. So I have the f function times the g function. And the f function is 2x times the g function, which is 3x. And 2x times 3x is 6x squared. So the new function that was created by multiplying this linear function times this linear function is a quadratic function. So that's the new function that's created by multiplying those two beginning functions. So we're going to kind of keep going with this, and we're not going to keep doing the graphing model because that would take way too much time to do each time. We're going to stick with the algebraic method, but I wanted you to see how the algebraic method came to be by using the graphing method. So here's the notation when we're going to multiply. Fg of x is f times g of x. And the domain is going to be the intersection of the two. And I'll try to explain what I mean by that throughout the next examples. Here, the domain on this one, I could put any values in for x. Here I can put any values in for x. So any value for x, the domain on this one is going to be negative infinity to infinity. When we divide, the domain is going to have just a few restrictions, and I'll show you what I mean by that when we get to a particular problem.